Today we're in San Francisco, California for Display Week 2016. I'm on the show floor at the Moscone Center and I'm at the New Vision Display booth. Joining me right now is Jack Powers. He's the Application Engineering Manager at New Vision Display. Hello, Jack.
Hi, Angie. How are you?
I'm doing great. So what are you going to show us today?
I'm going to show you some new backlight technology that NVD has developed at our backlight factory in Yangzhou, China. And basically, what we've done is incorporated the LEDs in the backlight to create a much wider color gamut, better luminous efficiency, which translates to lower power consumption. And as you can see by comparing a conventional backlight to what we call a Phosphor LED, the Phosphor LED has a lot more pop to it. And the way this happens is the conventional LED backlight combines the blue LED with the yellow phosphor and gives white light over a broad wavelength spectrum. While the Phosphor LED uses also a special blue type LED emitter, but it uses a red phosphor and a green phosphor that have a very sharp peak in the red and the green wavelengths, and that means that you're not wasting a lot of the white light that's outside of that. And so if you want to take a look, you can judge for yourself. The other nice thing about it is that it doesn't require any changes to the LCD panel design or materials. It just requires changing out the LEDs in the backlight element.
You could really see the difference. I mean, that really is amazing.
It is. You got good eyes.
Terrific. Well, thank you, Jack. And I understand that we're going to talk with Mehmet. Now I'm with Mehmet Tugrul. He's a field application engineer for OSD. OSD is a new division of New Vision Display, and they're focusing on OLEDs. So Mehmet, what are you going to show us today?
I'm going to show you some OLED displays.
Okay, terrific.
OLEDs produce their own light at the pixel level using the same principles as normal LEDs. Basically, OLEDs are made of thin layers of organic semiconducting material sandwiched between an anode and a cathode. When current is applied across the anode and cathode of the OLED, electrons and holes move through the semiconducting material. When they reach each other, they recombine and emit photons of light. The color of that light that's emitted can be controlled by changing the composition of the OLED materials used in the display. As long as there's current flowing, there'll be an emission of light. So when a pixel is turned off, there's no light leakage, as with some other technologies. Additionally, because OLEDs produce their own light, they don't require the additional power and thickness of a backlight assembly. Eliminating the backlight means OLEDs can be made much thinner and lighter than other display technologies. Here are some examples of monochrome passive OLED displays. In addition to the monochrome passive matrix OLED displays, we also offer full color passive matrix OLED displays. This is an example of a 1.5 128 by 128 RGB OLED. The colors are actually generated by the OLED materials themselves, and there's no need for a color filter. We also have transparent OLED displays where the OLED material is emitting light, but the substrate is actually transparent. This is an example. It's a 0.5 inch round, 60% transmissive passive matrix OLED display. We also offer active matrix OLED displays. Active matrix OLED displays differ in that they have two transistors at the pixel level. One transistor controls a capacitor which helps contain charge, and another transistor controls a voltage source which powers the pixel when it's turned on. This offers advantages over passive matrix because the multiplex rate isn't the limiting factor anymore. This is an example of an active matrix OLED that's currently in production. It's a 1.5 272 by 340 designed for wearable devices. Another active matrix OLED display we have in full production currently is a 5.5 inch 720 by 1280 full color active matrix OLED, available with and without on-cell cap touch.
Mehmet, thank you so much for taking the time to show us all the display technologies that you have, and we can't wait till next year to see what you might bring to Display Week.
Thanks.
Thank you. In San Francisco, I'm Angie Kellen for SID.